time for the last section of today. So it's not just me, it's my colleague Jim finishing off at the end as well. You've seen me before. I'm Michael Hungerer, running the developer relations engineering bit of the developer relations at Neo4j. That means we build a lot of data integrations, tools, visualization tools, and other things that enable people all around the world to have a better time and easier time to use Neo4j. And actually what I want to do today is really quickly run you through a lot of things. It will really be a lot, but just to give you an idea of what's possible. You don't have to understand every little bit of that. You don't have to remember all of that because you will also get the slides. But just to give you an idea of what's possible, and then knowing that you can later come to us, come to me, join the Neo4j Slack channel to ask questions if you have detailed questions for any of these things. So basically, I want to talk about how you can extend Neo4j, how you can use more powerful features of Neo4j, and by adding new capabilities for analytics and operations. So basically, it's 30 things in 30 minutes. So let's get going. So Neo4j started out as a Java library. Then we extended it to be run as a server, added a REST API, started to develop Cypher as a language, which was originally run via an HTTP API. But then in 2016, and that's where my starting point is, we started to add Bold as a binary protocol for Neo4j. We added official language drivers that you've already heard about today. And we also added the means to run user-defined procedures and functions in Neo4j as well. And many of the things that I want to talk about today are kind of based on these building blocks. Starting with the drivers, you already heard about them from Kurt today. So we have official drivers for Neo4j that run this binary protocol called Bold. And Bold is not so much about performance, but it's about capabilities. So first of all, Bold introduces a clear type system, which is not possible over JSON and HTTP, which is equivalent to the Cypher type system. But it also enables things like smart client features. So it enables us to do routing with clusters, to do redirect reads and writes to the right servers, to add additional security layers on top of that, to have custom routing policies and stuff like that. So it's kind of about the smart client bit as well. And as you've heard it before, we have also a lot of really good community drivers that support the Bold protocol. So from Swift and iOS, Elixir, PHP, Go, and Ruby, and other languages as well. OK, cool. So much for Bold. Bold runs Cypher over the wire. If you run Cypher over the wire, you also want to often use custom functionality that's not part of the language yet, or things that you can't do that easily or you can't do with Cypher in general. And so starting with Neo4j 3, when we added kind of Bold as a user service, we started to add or support user-defined procedures. And user-defined procedures basically allow us to develop extension code for Neo4j in any JVM language. So if you can write Java or JavaScript, Kotlin, Clojure, Scala, you name it, you can implement them and deploy them to your Neo4j server. So basically, those user-defined procedures and functions are a little bit of code annotated with a few annotations directives, and then Neo4j will pick them up and make them available as part of the Cypher language that you can run against Neo4j. So you can call them standalone, like you might have used in relation databases, where you have a standalone call for calling a procedure and it does something. But what's actually cool about the Neo4j procedures is, thank you, Stefan, is that you can call them as part of your Cypher statement. So you can imagine having a Cypher statement that finds some data, follows some patterns, aggregates some information, and then you hand it to a procedure to do something. And then the data that comes out of the procedure you can then continue to use in your Cypher statement. So the procedure, for instance, can encapsulate something like business logic or something like a certain security, encryption, whatever, you name it, thing as part of your regular Cypher code. So this is one simple example where we call a procedure, that gets passed in 2 parameters. In this case, it's kind of using a Lucene index under the hood with an index name and a Lucene query string. And what comes out of this procedure is a stream of data, a stream of nodes. And so this is the implementation. We don't have to go into details. Basically, you have an annotated method that gets parameter in, returns a stream of data, and then we implement our custom logic inside of this procedure. We can also get things like a graph database instance injected, and that's basically it, right? And if you just package this up as a jar, deploy it into Neo4j's plugins directory, then we can use them from Cypher. So from using it from a driver, so this is the Java driver, you would just create a connector to a certain URL with a configuration authentication, get a session from that, and you can run this procedure like you can run any other Cypher query as well. Get the results back, and you're good. User-defined functions are similar to that, only with the difference they're more lightweight. So you can use them in any expression. So where you have in user-defined procedures these kind of specific clauses that have a separate call statement and return a stream of data. With user-defined functions in every expression, be it a arithmetic expression, Boolean expression, predicate, wherever, you can use them. The big difference here is that they just return a simple data type, so they don't return a stream of data, but they just return a single value in general. So this is an example that joins strings. So Cypher doesn't have a join function, so we can just build our own, takes a list of strings and then delimiter, an optional delimiter, and then joins them up. And here what we do is we again annotate some code with user function, can put in a description, and as parameters we have like the list of strings as the first parameter, and the second parameter is optional because we also give a default value. So if you don't pass it in, it defaults to comma. And then we just join them up, return them as a string, and that's it. So it's kind of one line, more or less, of code that adds a new capability to Cypher that was not there before, and oftentimes saves you from a lot of annoying Cypher fragments or code to write. And again, if you want to run this from Bolt, it looks like this. And something that's much more powerful, which was introduced in Neo4j 3.2, is user-defined aggregation functions, which can be used like any other aggregation that you've seen in Cypher already, like collect, count, sum, average, standard deviation, percentiles, and so on. But you can build your own aggregation functions. And these are a little bit more involved. You basically use them like you use any other aggregation function as well. This is an example that just kind of computes the longest string of an input set. So each row of this input set gets passed through this aggregation function. And implementation looks like this. Basically, you have one bit of the implementation that says create the aggregator, because the aggregator has to accumulate state, right? Some kind of state to do the actual aggregation. So we create a new instance of the aggregator. And then for the aggregator itself, it has one method that gets called for every value that's passed in. And then it can update its internal state. In this case, it just compares the length of the string with the stored length, and only updates that internal string if the current string is longer. And then it's just a getter method that returns the data. And you can easily imagine with this kind of basic building block, you can implement any kind of aggregation function, even really complex ones. And you call them, again, from Bolt. But of course, I don't want you to all go home now and write your own custom functions for every utility that you would think of. We've already taken care of that, or most of that. So a lot of the work in the developer relations team has been around implementing extensions to Neo4j using procedures functions and aggregation functions. So you find most of them in Neo4j contrib. Some of them are also written by other parts of the company or by partners of ours. I'll show you some of those. Let's start with the epoch procedures, which is my pet peeve and my baby. So I started when Bolt was not even released with that. And nowadays we have more than 400 procedures and functions. And basically it's a Swiss Army knife or standard library of utilities. So let's look at a few of them. Something actually, they're good news. Something that you can do in Neo4j desktop is you can just install epoch with a single click. If you run a Neo4j sandbox, APOC comes pre-installed, and also Neo4j Cloud, it will come with APOC pre-installed. I'm sometimes joking that at some point APOC will come with Neo4j as an appendix. OK, cool. So we can just install APOC really easily, and let's now look at a bunch of procedures that we have there. So one is data integration, meaning I want to have an easy way of getting data from other data sources into Neo4j and from Neo4j into other data sources as well. So loading from relational databases is super easy. We just have a procedure that's called APOC load JDBC. We pass in a database connection string to any database that supports JDBC, which is almost any relational database on the planet. And then you pass in either a SQL statement or a table, and then you get a stream of results from the SQL statement back to Cypher. And then you can use that to create data, to match data, to update data, whatever in the graph. So it's a really easy way of getting information into your graph. So basically that. So it actually returns for every row that comes back from the relational database, it yields a row instance, which is more or less a map or a dictionary. And then you can use that in your Cypher statement to actually, in this case, we just create products and set up the information. OK, XML, basically the same. You have an XML on an API. You have XML on in a file. Lots of enterprise systems run on turning XML into stack traces or something like that. And so here it's the same. There's APOC load XML. We just pass in URL, which could be file or an API. And then we can actually deconstruct. So it turns the XML file into a nested document. And we can just use Cypher's dot syntax and array indexes and things like that, and operations like, in this case, like unwind, to turn an array of children in my XML into rows of children, and for each child of the element of the document, we do something. And we can filter and so on. So, and that's also quite interesting. So this loads data from OSM editing data, and so we just create points from the OpenStreetMap data, set them, and also can store which user edited this point, so because all the data is in the XML API. Same is true for JSON, so any JSON API is also supported. This is an example for Stack Overflow, so we can just take a Stack Overflow API call and turn it into a graph. So this takes all questions around the tag Neo4j and turns it into a graph of questions, users that have asked the questions, answers to this question, and users who have posted these answers. So with a single, and tags as well. So with a single statement, we can actually take a JSON document, turn it into a graph, which is kind of powerful. And because these JSON documents have a lot of nested arrays, we can also just use for each to iterate over the array and create data for every element of the array as well. So unwind and for each are two really useful Cypher keywords if you haven't used them before. Of course, graphs are not static, so we want to change our graphs, adapt our graphs to new requirements, to kind of new learnings that we have, so we can also refactor our graphs. And we have procedures for that. So one procedure is merge nodes, which is quite frequently used. Yesterday, I talked to someone from a newspaper that had like duplicates nodes in their data, and they said, OK, is there something that we can do? Yes, of course, we can use APOC refactor merge nodes. And it works like that. You aggregate your data by the identifying criteria. It could be something like the SSN, username, or email, or any kind of unique identifier, and you just collect all the nodes into a list. And for all the lists that have more than one element, you just pass this list to merge nodes, and it will merge all the data on the first node. There's also some configuration that you can pass in as an additional parameter that says how each property should be merged, so if it should override, if it should be skipped, if they should be combined. Sometimes you want to turn multiple properties into a list as well. OK, something that Cypher doesn't do by default and by design is you can't parameterize labels, relationship types, and property keys. But of course, there's also a procedure to help you with that. So there are procedures for creating nodes with dynamic labels, with adding labels to nodes, creating relationships with dynamic relationship types, and so on. So whenever you have data from a data source where the actual type or label information is part of the data, then you can use these procedures from APOC to add and set these dynamic tokens on your nodes. If you imported large amounts of data with a single cipher statement, you might have run into the problem that the transaction state of Neo4j exceeds your available memory. And that's why we added something to APOC that allows you to batch these updates. So APOC periodic iterate is a really nice function. So Stefan Armbruster came up with the idea that we have actually two cipher statements. One cipher statement kind of drives the input data stream, to say so. And the second statement is actually the workhorse that does the actual updates. And of course, we don't do it like one by one, but you can also batch that. So in this case, every 10,000 every 10,000 people are kind of updated in a single transaction. So every 10,000 elements, we do one transaction, so it never exceeds kind of the available memory. And if you have non-conflicting updates, like in this case, you can also parallelize that, which really makes nice use of all your CPUs if you have more than one. There are a lot of utility functions. For instance, turning text, which is really interesting for like text analysis and also journalistic use cases, turning text into phonetic representations, getting differences between text. We also have something like edit distance and other similarity metrics for text as utility functions. We have functions that extract email domains and URL domains from URLs, which could be sometimes handy. And the most widely used are text time and date functions to parse and format text. So basically, you have your input. In this case, input is a text. I specify the granularity. I want to have seconds as a time granularity, and then a date format, and it parses the date for you. The same thing the other way around as well. So you can take a timestamp in milliseconds, format as a date of any kind of format that you want to have. Really useful. And many more. As I said, it's 400 of them. So there's also comprehensive documentation, and you can find all of them there. Something that we get asked quite often are relationship between RDF, triples, and property graphs. And something that many people want to have is a way of importing RDF data into Neo4j. So my colleague Jesus wrote a library called Neosemantics that allows you to take arbitrary RDF data, import it into Neo4j, but also to expose data in Neo4j as RDF URLs as well as linked data. And he wrote actually a bunch of blog posts about that, which are super informative. I recommend you all to go and read them after my talk, after Jim's talk, I mean. And so the last blog post that he did was importing Thomson Reuters data, which was really a nice read and really interesting. So this is what like triples in RDF look like. You have a lot of UIs, a lot of dots and spaces in there. So it's always subject, predicate, object information. And then you basically call just a neo-semantic import RDF, and it turns it into a property graph out of the RDF data, which is really nice. So it then looks like this. And it works really well because it also batches and parallelizes the import as well. OK, graph-aided search. Of course, in Neo4j, there's a number of means of working with more complex search operations on text. But sometimes you want to integrate it with an external search engine, for instance, like Elasticsearch. And our friends from GraphAware built a really nice integration between Neo4j and Elasticsearch that you can also just deploy to your Neo4j instance, set some configuration options, and then it takes care of sending data from Neo4j to Elasticsearch in an ongoing manner. So whenever you update something in the graph, it hooks into the transaction system of Neo4j and sends this data to Elasticsearch. And this goes both ways. So you can also enhance Elasticsearch, for instance, scoring and boost plugins by taking information of the graph into account while returning that. So basically, as I said, you set some configuration, deploy the jar, and then it's ready to go. And then from within Neo4j, again, you can use it with an user-defined procedure, and this kind of passes in a query to Elasticsearch. Elasticsearch is called, you get the data back, and then you can use that for your graph query. So it's always kind of the combination of the system. Systems allow you to make the most out of each system and combine them to get the most value for your application or for your product. And here you get, for instance, much more interesting scores from Elasticsearch than you would get from a pure Lucene lookup in Neo4j, because you can have all these boosters and additional information going into the scoring as well. Okay, and as part of our joint efforts, we also published a DZone ref card that kind of goes into detail. So if you want to learn more about Neo4j Elasticsearch integrations, please go ahead and download the ref card. Graph versioning is something that we've get also asked quite often. How do I kind of version graph? What if my data has to be updated, but I have to keep track of the old information? And this is also a project from one of our community members called Neo4j Versioner, which allows us to specify entities. In this case, it's a device, and I can specify which part of the entity's attributes are fixed or static, and which parts are dynamic and can be updated. And in this case, here's an example for a person. So we create a person where the first two attributes are fixed and immutable, to say so, and the other attributes are mutable. And when you then want to update this data, you again call a procedure it's called versional update, and then you pass in the new data, and it creates this data structure that we just saw that represents kind of the succession of states of data, so you don't lose the old information, because if you want to send a person a package and you only have the old address, then you actually want to see what's the current address, so you want to go forward to that, for instance. Many people are also really interested in using Neo4j and geo information. And actually, the Neo4j spatial library was one of the first Neo4j extension libraries. It has been around for almost 8 years, I think now. Built and maintained by my colleague Craig Taverner, who's been putting a lot of effort into it and has basically implemented full PostGIS support for Neo4j, including well-known tags, multi-polygon intersections, envelope search, and all the other things. And actually, with the advent of Neo4j procedures, we could make it all available to Cypher. So from within Cypher, you can now use the spatial library by just calling a number of procedures. And here's an example. So my other colleague, Will Lyon, had this really nice example of mapping US congressional districts in Neo4j. So each district has a very complex polygon that kind of forms the shape of this district, and then you have other information attached to this district, who's the legislator, what bills did they vote for, what party are they in, and so on. And if you want to add this to Neo4j, we have to take basically 3 steps. First step is we just create a geo-index with this name geom, could be also kind of districts if I want to call it something else. And I say which property of my node contains my spatial information, WKT, well-known text. And then we basically create our nodes with this data, so districts in this case, and set the spatial information on this property. And then we get our data and call a spatial procedure to add these nodes to the spatial index. And then they are integrated in the R tree that the spatial index creates, and I can start to query them. So when I want to query them, basically I say, give me all the nodes that are in this index around this point, or where the polygon of this node, in this case, is around this point within 1 kilometer distance. So I have a geolocation, and for instance, if I click on the map, this is my starting point, and I say, okay, every polygon that is closest to this point. Then I get a node back from the index, and then starting with this node, I can do my regular graph matching operations. So for this district node, I can fetch the legislator, I can fetch the committees, I can fetch the bills that I voted for, and so on. And then use that to build an app that presents that to a user. So that was made, so these user-defined functions procedures in spatial made it really easy to integrate it with any app that runs Cypher on top of Neo4j. Something else that I'm really interested in, and I started with that actually last year to kind of integrate or try to integrate Neo4j with machine learning, is something that, again, our friends from GraphTour have spent much more time and effort into doing. They put a lot of focus on NLP, so natural language processing, natural language analytics, so you can analyze texts from, let's say, documents, papers, patterns, news articles, detect entities, detect organizations, detect locations and other things, and then with this enriched information you can do your application building. So again, it's a project that you can deploy to Neo4j. It's called Neo4j NLP at the GraphQL repository. And here's how you would kind of use that. So here, in our case, we have a news article which has some text, and we want to take this text and annotate it. So it doesn't matter what kind of source it is. It could be, as I said, lots of different sources that we want to annotate. So we basically get our data. So we match our news articles. We pass it to the NLP annotate procedure, which does all the heavy lifting. So it uses either Stanford NLP or OpenNLP Corpora to do the analytics, and then creates a graph structure that represents kind of the NLP analysis. And here in this case, we kind of connect our news item to this information. And basically, it looks like this. So the yellow one is our news item, and then it splits it up into like a paragraph and multiple sentences, and then each sentence has all the elements, all the kind of parts of speech, and then also the recognized named entities like people, locations, dates, durations, and organizations, and so on. And then you can use that to extract more value out of the text. So you could remove all the stuff that you don't need and keep only the text that you're interested in. You can also configure what's created as part of this call and use that. And we've already heard about graph algorithms today. Really quickly, what we want to enable everyone to do is kind of gain insight from structure, because graphs are a lot about structure. And actually, it's really interesting how basically stupid algorithms can take the structure and get insight out of that. So one really cool example that is very close to my heart is the Game of Thrones interaction graph. So there's a mathematician in California called Andrew Beveridge, who kind of used all the 5 books of Game of Thrones and used some textual analysis to extract character interaction. So whenever 2 people interacted with each other, that kind of became one interaction. And the result of that was a graph where the strength of each relationship was the number of interactions. And on top of that graph, he just ran a bunch of graph algorithms. And interestingly, they came to the same conclusions that I, as a human, come to when reading the books by just looking at the number of interactions between people. So they know who are the central figures, which clusters or which groups are in these books that kind of interact with each other quite often, who is connecting clusters of people, and so on. So that was kind of really interesting to me to see how the algorithm, without actually understanding the content of the text, just by looking at something like the interactions, could kind of come to the same conclusions as you as a human reader, kind of understanding the text. So as Kurt said today, we implemented a number of algorithms in Neo4j really efficiently. So we try to use super efficient data structures, so we can also deal with billion node and billion relationship graphs. We use parallelization everywhere, so we can easily saturate hundreds of CPUs as well. And implemented all these algorithms which can help us to get more insight from our graph data and enrich our graph with scores and information that we then can use in our transactional queries to get better results, for instance, for recommendation, for fraud detection, and similar things. Fortunately, since a few weeks, you can also install graph algorithms as part of your Neo4j desktop. And I think they will also be available in certain cloud instances as well. Basically, you call them as procedures again. We have 2 versions of that. Actually, 3 versions. We have one version that streams results back to you as a user, which makes sense for smallish graphs, so tens of thousands or hundreds of thousands of nodes. But you probably don't want to have like a billion node scores have thrown at you. That's why we have a second version where you call the algorithm and just writes the results directly back in parallel to the graph as well. And that works really well. And in the third version, that was the one that I showed today as well. That's the one that allows us to use two cipher statements to create a node list and a relationship list and pass that as a virtual graph projection to the algorithm and run that algorithm on top of this virtual graph. If you look at dbpedia, it looks like that. So dbpedia has 11 million nodes, 160 million relationships. And in 20 seconds, we can run PageRank on that. And here we stream back the top N results. I think the thing that takes longest is the sorting and cipher afterwards. And we can also identify clusters in dbpedia and then visualize them, for instance, in the Neo4j browser as well. There's also a sandbox that comes with graph algorithms installed. So if you want to try it out without installing anything, then you can do that as well. We've seen a lot of graph visualization today. One graph visualization project from one of my colleagues, Will Lyon again, is Neovez, which is a combination of Neo4j and Viz.js. And that's the one that we've seen for the Game of Thrones data, which allows you to configure Viz.js to use, for instance, PageRank for node sizes, colors for communities or clusters, and then the weight on relationships for the thickness on relationships, and then just run a statement, visualize the graph, and then you're good to go. And my last thing is, or almost my last thing, is GraphQL. Really quickly, GraphQL is a language for querying APIs. And we want to enable people that want to use GraphQL in their modern web applications built with React, for instance, to integrate with Neo4j really well. And what is really nice about this is that it comes with a very strong type system, which allows people to build really good tooling around GraphQL, where you get documentation, code completion, and so on. And, sorry, it looks like this. And this type system looks actually pretty similar to what we see as a graph model. So you have entities that have relationships to other entities and properties. So it looks like the labeled property graph model. Of course, you can do it manually, kind of just by implementing cipher statements for each of those, but of course, that's not a lot of fun, obviously. And so we built two libraries that allow you to do this automatically. So one in Java and one in JavaScript. The Java one you just deploy to Neo4j, and you have a GraphQL endpoint. The JavaScript one you would run in your Express server as a backend, which allows you to build JavaScript applications doing that. Basically, the extension one, you just install into Neo4j, configure something, and then you can just post a GraphQL schema. And as soon as you do that, you have a GraphQL endpoint serving that schema on top of Neo4j. So here we can just run a GraphQL query on top of the data, or you can use just the GraphQL endpoints as well. The JavaScript library is special because it doesn't just add this capability, but it's also the basis of a full stack that we defined using that. So Neo4j GraphQL.js is part of the Grand Stack. The Grand Stack stands for GraphQL, Apollo, React, and Neo4j database, right? Proper acronym. And it's pretty cool because it combines all these technologies which are fairly modern and easy to use and enable you to build quickly modern web applications on top of Neo4j. Basically, you just implement a resolver for each query type in GraphQL, and the Neo4j GraphQL library takes care of turning your tree-structured GraphQL query into a single cipher query, runs it against Neo4j, maps the results back, and you're good to go. Will also published an DSON ref card, so if you want to know more about Grand Stack and GraphQL and Neo4j, feel free to look this up. And if you want to learn more, if you have questions, want to have quick answers, join our Slack channel. Actually, today we're already at 7,250 or so users, so like 100 people are joining every week. And you get really quick questions, answers there, which is really cool. And you should also check out This Week in Neo4j, which is compiled every week by my colleague Mark, and it's an amazing collection of activity and projects and things around the Neo4j community, which are super interesting. Last but not least, because we are in Berlin, I have a group of students at the HPI in Potsdam working on a graph exploration project. It's called MetaExp, which uses metadata from the graph to enable better understanding of complex large graphs. So and they're currently looking for other use cases that they can apply their approach on, not just the biotech life science domain that they're currently using. So if you have a complex graph and you want to know more, let me know and I'll bring you into contact with them. And with that, thanks for your attention. And if you paid attention, there was actually not 30, but 28. Thanks. Thanks a lot.